Hello everyone, let me walk you through how to do worksheets with types of chemical reactions. So there is 3 steps you need to follow. Step 1 is you need to determine which of the 6 types of chemical reactions take place on the specific problem. Step 2, use the type of chemical reaction in order to predict the product. In addition, make sure that you balance the chemical formulas as we learned before. Finally, you need to balance the chemical equation. Let's do some examples. Okay, so we have hydrogen plus oxygen. If I give you hydrogen plus oxygen, if this is the only thing I give you, and I said predict the products, what you need to do is you need to decide what type of chemical reaction takes place in this situation. So, hydrogen plus oxygen, you put them together, that's synthesis. So step number 1 is you say the type gonna be synthesis. Step number 2, when you put hydrogen and oxygen together, they create water. You need to balance water. Water is H2O. So you don't write H2O2, you write H2O. They create water. And finally, you balance the equation. In order for the equation to balance, you have 2 hydrogens, you have 2 oxygens, you have 2 hydrogens and 1 oxygen. You need to put a 2 in front of water to create 2 oxygens. That makes 4 hydrogens. You need to put a 2 in front of the hydrogen to create 4 hydrogens too. This is a balanced chemical equation. This is the process that you do in each simple example. So, example number 2. You have one compound. Therefore, what type of chemical reaction you expect? You expect decomposition. You expect the 2 elements in the compound, potassium and chlorine, to decompose to potassium and chlorine 2. Why chlorine 2? Chlorine, it's a diatomic element. Therefore, when it decomposes, you write chlorine 2. If you do not know that, that's fine. Okay, so you have potassium and chlorine. The first step was determine what type of chemical reaction was decomposition. And then you balance the chemical reaction. So in order to balance the chemical reaction, you have 2 chlorines here, you put a 2 here, now you have 2 chlorines, but that makes potassium 2, therefore you put a 2 in front of the potassium, now potassium is balanced. Let's do the next example. In the next example, you have copper, 1 element, plus silver nitrate. You have 1 element and 1 compound. You should assume that this is a replacement reaction, a singular replacement, where the copper gonna replace the silver. So it's a single replacement reaction, and you have copper replacing the silver. So in products, you're gonna predict that you have copper nitrate plus silver. Step 2, it's after you write the products, you need to balance the chemical equation. The charge of copper, it's plus 2. Therefore, you take the charge of copper and you put it here. The charge of nitrate is -1, therefore you do not write anything, plus silver. Step 3, you balance the equation. In order to have, because you have 2 nitrates here, you need to put a 2 in front of the silver nitrate. Nitrates are balanced, but now you need to balance the silvers. You have 1 silver here, you put a 2 and you balance the silvers as well. The next reaction, you see 2 compounds. Compound 1, compound 2. If you have 2 compounds, you only assume that it's a double replacement reaction. So you have Ba, barium, replace sodium, therefore you get barium carbonate, and sodium replace barium, you get sodium nitrate. Okay, so after you follow a double replacement reaction procedure, you need to make sure that you balance the formulas. Okay, so in this case, barium, it's +2, carbonate, it's -2. When you put them together, they cancel each other. Sodium it's 1, nitrate it's 1. Therefore, you get sodium nitrate like this. Now, in order to balance, the only thing is that you have 2 sodiums here, therefore you put a 2 in front of it. And also you have 2 nitrates, these 2 also balancing the nitrates, and this is a balanced chemical reaction. And you are ready to move to the next example. The next example is a hydrogen in front of a non-metal, and that makes an acid. And then we have a metal with a hydroxide group that makes a base. Every time you have an acid plus a base, you expect a neutralization reaction. So, after you determine what type of reaction you have, you know that a neutralization reaction produces water plus salt. So you write water plus salt, which are made of the metal and the non-metal, and then you make sure you balance it. Water, it's H2O, and sodium, it's +1, fluorine is -1, so it looks like this. In this case, the reaction is balanced because you have 2 hydrogens, and you have 2 hydrogens, 1 oxygen, 1 oxygen, 1 sodium, 1 sodium, 1 fluorine, 1 fluorine. So it's already balanced. You do not need to balance this one. The final example, it's a combustion. And how do you know it's a combustion? You have a hydrocarbon, carbon and hydrogen, with oxygen. Every time you have hydrocarbons with oxygen, it's a combustion reaction. And the products are always carbon dioxide, water, and energy. You do not have to write energy as a product, because energy, it's not atoms, it's energy. You can write it there if you want to. So after you decide what type of reaction it is, you make sure that carbon dioxide looks right, water looks right, and make sure that you balance the equation. In this case, to balance the equation, you need to put a 5 in front of oxygen, a 3 in front of carbon dioxide, and a 4 in front of water for all elements in the reactant and the product side to be balanced. Combustion reactions are the hardest ones to balance because usually you need to put big coefficients in front of them, as you notice in this example. So, in this tutorial, I show you how to predict the products. If I give you the reactants, how to predict the products, and how to balance the equation. In summary, to predict the products, you need to figure out first what type of chemical reaction you have. Second, based on the type of chemical reaction, you write the products and you make sure you balance the formulas. And third, you balance the chemical equations. Thanks for watching. See you next time.